Okay, so till now we have talked about this previous sequence evolution, right? So in this HR diagram, increasing temperature, increasing luminosity, we talked about this scenario, something like this. This we talked about, right? And we talked about newborn star, and then we talked about hydrostatic equilibrium. Good. But suppose the mass of the core is such that, suppose the mass of the core is just 1 into 10 to the power 7 Kelvin. What will happen? Temperature is high, but there will be no fusion. Then what will happen? There will be no fusion, and slowly that prestellar mass, the entire star, we will not call it star. Why? Because there is no fusion, and it will be named as brown dwarf. So basically, you see, so for that we have to find the lower limit for a star, and that is, I have done some calculations in my previous classes, you can check the lectures. The lower limit is around 0.08 solar mass. So if the mass of the fragment is around this, then the core temperature will be high enough to initiate nuclear reaction. But if the mass is lower than that, then there will be no nuclear reaction, and slowly the star will cool away. And this is known as your brown dwarf. Now, what about planets? In a way, what is a brown dwarf? In a way, brown dwarf is a failed star. Although it's a fragment which has formed due to contraction and all that, but because of the fact that there is no fusion, we will call it a failed star. So, brown dwarf. Brown dwarf. Right. Now, what about planets? You see, mass of Jupiter is around 0.001 solar mass, and planets, they are defined to have masses less than 12 times of Jupiter mass. So, mass of planets is less than 0.012 solar mass, right? It's less than that. So what about brown dwarf? What is the range of mass of brown dwarf? Brown dwarf will have mass lower than the lower mass limit for star, that is, it will have mass less than 0.08 solar mass, because this is the lowest mass star where fusion will happen. So brown dwarf's mass is less than that, and it is of course less than this, greater than this planet's mass, because planets have masses lower than this limit. So in this range we have the astrophysical objects which have failed to become stars. We will call them brown dwarfs. They have masses in this range, and this is the mass for the planets. Right? So keep this in mind. Any more questions? So one question from my side. One question. So I am telling you that we have got a star of mass 0.5 stellar mass. 0.5. Right? So let me write it down, 0.5 solar mass. Another, so I will not call it star, I have got a object having 0.5 stellar mass, fragment. Another is 0.0005 stellar mass. Right? And another one is 0.005 stellar mass. So can you tell me which of them is what?
The first one is star became
First one
star.
will form a star.
when it is nuclear fission started.
will be initiated because the mass is greater than 0.08. Okay, next one.
Planet
Planet. Because the mass is
less than
lower than this value. Right?
brown dwarf.
What about this one? This is
Next
a
one
planet.
is the gas.
Okay. This is a brown
brown
dwarf.
dwarf. Yeah.
Okay. So this is the first question. Next question. If I want to draw this, we want to point this in the HR diagram. Where will they lie? In the HR diagram, the first one, 0.5. So if this is the sun, this corresponds to sun 6000 Kelvin. The 0.51 will be lower than that. Right? It will be lower, 0.5. This corresponds to 1 solar mass. This will correspond to 0.5 solar mass. What about the other two?
Main sequence is asking us.
You will not be able to plot.
Main sequence is asking us.
Remember the stage 3 after which we were able to plot this on the HR diagram. Okay. It is too low. The surface temperature will be too low. The luminosity will be too low, and we will not be able to see this in the HR diagram. So keep this in mind if I ask you such questions. So basically the questions will be involving all these ideas together.